So these are the definition that you need to understand. The first one is called lightning electromagnetic impulse with respect to this chapter. LEMP, electromagnetic impulse, is defined as all electromagnetic effects of lightning current via resistive, inductive, and capacitive coupling, which creates surges and electromagnetic fields. So remember, all the mechanism, resistive, inductive, and capacitive, due to the lightning current, is called lightning electromagnetic impulse. So it can be radiated, so usually inductive and capacitive, or it can be conducted, usually resistive. So those LEMP, by any means of coupling, will create either surge through the wires or electromagnetic field that interact with your equipment. So your equipment is actually connected by wires, right? So the surges can come in through the wires, or the body itself is under the influence of electromagnetic field due to the radiation. So LEMP cover both radiation as well as conduction surge. The surge is defined as transient created by LEMP. So usually surge means something that goes or propagated inside wires or transmission line. And it appears as a voltage, over voltage, or over current, because it's abnormally high. So we call it over voltage or over current. So transient created by LMP appears as an over voltage over current is called a surge. The zone is defined by how you limit your radiation, as I've shown just now, by putting shieldings, or in the case of surge, you limit the surge by using surge protective devices at the boundaries. So you have two, if you like, the zone. If you have shielding from radiation, you can have the first zone, second zone, and so on by cascading the shielding. Or if you have conduction by surge, you can put SPDs at the first boundary, and then you put another SPD at second boundary, you have second zone, and so on. LEMP protection measures, SPM, which is the chapter part 4 of the standard, is actually the measures taken to protect internal system against the effects of LEMP. Any questions so far? Consider inside this chapter, first the source, LEMP. Second is the bonding network. So this is mitigation. You need to make sure you have a good bonding. For example, for surges, we need to bond all the conductive parts to the internal system. Okay, all the internal system, all conductive part to the earth termination system. So all has to have bonding. So bonding is actually connection, everything to the earth termination system. Earthing system is actually complete system made up of two things, which is earth termination system, the one under the soil, and the bonding network. Okay, so it can go up as well. I mean, into the structure, you have all these metal works bonded to the earth termination system. We call it earthing system. Surge protective device, I think you understand this. Is example are the SPD are Zener diodes, metal oxide varistors, and so on. The purpose is to limit transient over voltages and to divert surge currents. And it contains non-linear devices, for example, diodes. Okay, SPD, when you want to test them, you can test them using many current shapes. For example, you can test them using 10⁻³ as shown here. So 10⁻³ means the front time is having a 10 microsecond and the tail is actually 350. So this is should be a very long tail. So the tail is like this, 350 microsecond. And the front is here, 10 microsecond. But you can also test them using 820. meaning the front is 8 microsecond and the tail is 20 microsecond. Why do we have a difference like this? The first one, the 10350, is actually the direct current, like the channel current I was talking about, or the down conductor current. So this is the direct lightning current. Whereas this one, 820, is actually the induced current due to coupling effects. For example, electromagnetic field coupled with your conductors inside your structures produce a surge, and that surge is usually 820 microsecond shape. Okay, so that's the difference. So when you want to put an arrestor or SPD at the front, at the main board, at the front entrance of your wires into the house, you should use this one, because that one is to the if you have a lightning strike to the wires, so the whole lightning current can propagate. But if you want to protect your equipment, for example, because of the induced surges, you should use the other one, because this is based on the induction. Okay, there are many testing wave also. There is also so-called combination wave. Combination waves is basically when you there is a generator here, impulse generator. It has a certain surge impedance, and this is your test object. Test object is usually your, for example, your SPD, and when you short this one, short circuit, it will produce 820 microsecond current. But when you open it, it will produce 1.2/50 microsecond voltage. Okay, so this is a combination wave, meaning to say if you want to check your SPD, you can use this generator. Okay, voltage switching versus voltage limiting SPD. So there are two types of SPD, surge protective device. The first one is voltage switching. It means the SPD actually will turn on. It's like a gap. It will turn on or it will break down when the voltage is over the limiting voltage. Whereas voltage limiting is more like a non-linear device, whereby the voltage will change with the current in non-linear fashion rather than a step or we call it crowbar as in voltage switching. So there are two types. So here is like Zener diode. So here is like a gap, a spark gap. Okay. Combination type SPD, meaning we can combine these two type of SPD, the voltage limiting and voltage switching. The coordinated SPD system, it means we have many zones, so we coordinate. The first zone may be the higher current or the faster, the 10/350. The second zone is 820 and so on. We can also use at the boundary isolating interfaces to actually protect our zone inside the zone, the equipment, by isolating the wires connected to the zone. For example, using transformers, or we call it isolation transformers, or you can also use opto-isolators. It means there is no connection between the two systems. The incoming line actually isolated to the receiving end by optically. Design and installation of SPM. So I've already mentioned just now, there is a term called zones. So when you do your risk analysis, you should define, or when you do your assignment, basically, you should define your zone inside your structures more than one. If you use zone 0, it means outside the structure. Zone 1 is inside the structure. But you can also go to zone 2, zone 3, and so on by putting shielding or by putting SPDs at the entrance of your rooms or inside the structure to define the zones. Okay? I hope you do this. So when you have a zone, that means you define the boundary. You find the boundary, and at the boundaries, you put shielding throughout, and you also put surge protective devices at the boundaries. So if you want to consider radiation of magnetic field, you want to shield your equipment from radiation, you should shield them. So the zone is by shielding. But if you want to just consider the conducted surges into your equipment, there's no radiation. For example, your equipment already EMC protected, EMC compatible, because it has a shielding on its own. But the wires you need to protect from the surges. So then you define the zone by the surge conduction only, and therefore at the boundary you put surge protective devices. So what zone or how many zone that you need, who decide?